Hello, welcome back. This is Calculus by Dr. Oz. Today, we're going to go over an exercise where we are given rectangular equations and we're asked to parametrize these rectangular equations with a specific property. Like in the first case, we want the curve passing through the point at -2 and -7 whenever t is equal to a -1. And in the second case, that we have an equation of a parabola, and when we parametrize it, we want the curve passing through the point 1 and 3 whenever the parameter is equal to 1. And obviously, there's no unique representations of these curves or these parametrizations. So why don't we get started and see the details within the video. All right, this time we're trying to get the parametric equations from the given rectangular equation, but we want the parameterization very specific in a way that when t equals -1, we want the x to be -2 and y to be -7 for part A. And we are given the line y equals 4x plus 1. And one way to handle this is just, since t equals -1, must spit out x equals -2 and y equals -7. So why don't we choose x to be t minus 1, right? Because when I plug in -1 here, then I'm going to get right away x equals -2, okay? And by choosing x to be like that, I can plug everything back into y so that I can get the parametric representation of y. So this is 4t minus 3, okay? So essentially when you plug in -1 for t here, okay, so you get -7 for y here, okay? So this is just one parameterization of the line. So the question is like, can you find other parameterizations? Sure you can. Let's just find another parameterization. So let's go with x equals t squared. T squared for t equals -1 is 1, but I want to get -2 in the output, okay? So then I should subtract 3. So for sure, at t equals -1, I have x equals -2. No problem with that, right? And also, I'm going to find y according to what I chose for x. Okay, so it's 4 times x plus 1. That takes you to 4t squared minus 11. So this is another parameterization of the same line with different representation, right? So and you can pause the video at this moment. You can have your own representation for the same line if you want to. Okay, so let's move on to part B in the same video. We have y equals 4 minus x squared, and I want at t equals 1. I want x to be 1 and y to be 3. Okay, so let's choose x. So x, since at t equals 1, x equals 1, I'm going to choose x equals t. How about that? Okay, if x equals t, then y, accordingly, is going to be 4 minus t squared. And as you see, that 4 minus 1 squared is already 3, so that's one set of parameterization of y equals 4 minus x squared, which is a parabola. Okay, can you find another representation? Yes, you can. For example, I can choose x to be t squared, so that when t equals 1, x is still 1. And if you want, you can choose this to be t cubed, right? Because you still have x to be equal to 1. But this time y is going to be 4 minus t squared squared. So therefore, it's going to be 4 minus t to the 4th. Okay. So you always have different parameterizations depending on what kind of question you're dealing with, and this is not the parameterization is not unique in some sense, and this is obviously being used in NASA applications. When you send a rocket to the moon, it follows a trajectory, and trajectory is generally determined by parametric equations, and the speed and the location of the shuttle or the rocket plays an important role to choose the right parametric representation. All right, because it tells you how fast you go in that trajectory. So that is the choice of the parameterization. All right, so I think in one with one stone we hit two birds this time. So we had two parts out of the way. Thanks for watching. If you have any questions or comments, please send those to my way. Bye.